Can we
Yeah.
look at some tests? Because this is always my favorite part of any
Okay.
project, and usually the part that people feel least happy about. Um, talking
Um,
about engineers' intuition. So, do we
True.
have any tests as yet?
We do. We do. Actually, we have. I don't know. I don't know. I think we have. I don't know what to call them. Integration tests or unit tests. We have the
Hmm.
test for the API for the handlers and test for the database methods. So, which one do you propose we start with?
Anywhere, let's just drop in at random and
Okay.
see. And
Let's.
it's sometimes a blurry line, isn't it, between unit and integration
Yeah.
tests. I don't know if there's really a hard and fast definition of these. My way of thinking about it is fast and slow tests.
Sure. So what we are looking at right now is the end. I would say this is like the entry point to the tests, to the whatever they call them, unit or integration tests.
Hmm.
So we'll start with the new test database because we need a database to test with. So this method here, this function rather, sets up the database container in Docker
Yeah.
and returns an initialized store object with all the fields set for use.
Right.
So you can
Yeah, I mean,
see,
if we're really talking to a real Postgres, I would call that an integration test because like we need some other
yeah,
process,
uh,
which makes it slow
I,
and expensive, and we probably don't want to run this every 10 seconds like I do with my unit tests. Um,
yeah,
and that's fine.
so,
We totally need this type of test, don't we? What
yeah,
the
yeah,
ideal thing is, the way I was thinking about it is, if I let's say I introduce some bug into some line
yeah,
of my program, or maybe there's one there already.
yeah.
How many tests should that break?
I think so many.
Ideally, I would like it to break exactly two tests.
Yeah,
I'd like it to break my end-to-end integration test, which tests the entire thing. That just tells me, is anything broken in the entire thing?
yeah,
But when it is, how do I know what's broken? Well, the answer is some very focused unit test is also going
yeah,
to fail. It's
exactly.
going to say this really tiny function returned the wrong thing. So
Yeah,
I have both the two crucial pieces of information that I need. One, that something's wrong. Secondly, what it is, or where it is, rather. Um, and that's quite a powerful principle, isn't it? Because let's think about the alternatives. If you have a bug and it doesn't break any tests, that's clearly wrong.
yeah,
You're missing some tests, aren't you? Or your tests aren't really testing what you think they are.
I agree.
If you break 97 tests,
Hmm.
and believe me, I've seen this happen, that's also a problem, isn't it? It means many of your tests are actually exercising the same piece of code, and it's too much noise. If you break that one thing, how do you know which of those 97 tests to start looking at?
Yeah, sure.
It's very
Uh,
demotivating. So,
Very. Mm,
I think well-structured tests will work exactly this way, that any given bug will break the big integration
yeah.
test and one or two small unit tests.
This is actually just to be, let me be honest up front. This is the area which I'm less confident about because I kind of like hacked this, I think, a couple of days before during this week.
Yeah,
Uh, Previously, I was using a Docker Compose file to set up the test database, but then I realized I wanted, to myself, I didn't like that experience of having to each time I need to, either have a make file that, sets up, the test database container.
yeah,
I wanted it to be programmatically in the code. You just run go test and everything just runs. Either the
yeah.
tests pass or they fail.
No, this is fantastic. I mean, I see people use Docker Compose a lot, and it's super convenient for stuff like this. It's usually Postgres that's
Yeah,
required. Um,
yeah,
but
actually, yeah.
as you say, now we've sort of subtly broken our test process in that you can't just run go test because it'll say no, couldn't connect to Postgres.
Yeah,
Now you need a shell script or a make file, or you need to do two things
exactly.
or whatever, and it just becomes complex. And if there's more than one of those things, maybe two or three different
Yeah.
dependencies that you need to set up, now it becomes such a pain to run the test that in fact no
Uh,
one will.
Actually, that was the case in this very project. I had a shell script that would, tell the container. hey, wait until the database container is up and running so that you can connect to it, which
Right.
was on hindsight, I realized that it was too much, it was too much, and it was a distraction actually. My goal was not to write shell scripts that do certain
Yeah.
things. My goal was to write unit tests.
Yeah. So overwriting shell scripts.
Yeah.
Um, so this is great. I don't think I've actually seen anyone do this before, but it's very, very cool. Just
Uh,
do it all from Go. We have a real programming language. Let's use it.
Yeah, actually, I borrowed this idea from the Google project exposure notification service. Then I looked up the Docker test library documentation and read it, and experimented with it. Yeah,
Great. You know, every
and
good idea that I've ever had, I stole it from some other project.
yeah, actually,
I've never thought of anything original in my life.
I think we'd agree retouch is steal rather than copy. They actually steal an idea and make it better, right?
Yeah, totally.
Yeah, yeah,
And this sort of implies that we spend at least part of our time just reading other people's programs
yeah,
for in a speculative way, isn't it? Rather than saying, I need to know how to start Postgres, we might just read code and we might come across 4 or 5 really good ideas that we
yeah.
didn't know we needed and say, wow, I'm going to make a note of those, squirrel that away for the future. I do this all
Yeah.
the time, and, it's gold. It's the best investment of my time I could ever make because I just, when I bring that out in a consulting session, everybody goes, "Oh
Yeah.
my God, this is amazing! How did you come up with that?" I don't really want to say, well, I read it on GitHub.
Actually, I usually don't. I sometimes, depending on who I'm talking to, I usually don't say where I read it. I'm just saying,
Yeah,
I'm experience and stuff. And
yeah,
also sometimes wanna look good.
yeah, that's right. So
Yeah.
this is very good. So should we see the test that uses this? So this is the helper that starts
Okay.
the database.
Yeah,
So somebody
that's the
calls new
helper.
test database.
Somebody calls the test database. Let's see who calls the test database. Oh, sorry. I just Let's see who calls. My
And,
my my VS Code is kind of lagging.
and the nice thing to do, I think, is to, in your test files, put
Yeah.
the tests first and then the helpers at the end.
Oh,
Because
okay.
you
Okay.
can see the argument for doing it this way in that like these functions are used by all the tests, so they should come first, you know. But actually, Go doesn't care, you know. Order of functions doesn't matter in a file. And as far as the reader's concerned, what they want to see is the test, isn't it?
Sure. Yeah.
In fact, we should probably start
Uh,
with the most basic test,
in the same
and
file.
yeah, and then go on to more and more advanced tests, and then at the end, maybe, or even in a separate file, maybe the test helpers like this.
Oh, yeah.
So I
Okay.
think so
Okay.
this is the whole file, isn't it? You don't actually have any other tests in this store test.go,
I have actually
or do you?
all these files are actually they are calling the new test database.
Right, but there's nothing else in this file.
Yeah, nothing else.
Yeah. Okay. So yeah, that's all right. I don't. I think everybody has a different preference for how much stuff there should be in a file, don't they?
Yeah.
Like, I'm. I think I'm probably a long filer. You know,
Oh,
some of my files are like 500 lines, um, and obviously I'm okay with that. Other people are absolutely horrified, and they go, "We, I need to break this up into 60 separate files of 5 lines each." You know.
yeah, I agree. I agree with you. For me, it depends with the project. Some projects are really, really force you to have such long files because you have so many functions, especially when you're writing networking code. You find yourself spanning even more than 500, almost 1,000 plus lines in like one file. Then you realize then I need a package,
Yeah.
Yeah,
So I think it's up to you, whatever is more
yeah,
logical for you or the program. What I will say is thinking back to Code Club, if you open some big project on GitHub and you look at it and there are like 75 Go files there, that's that's really off-putting because you just don't know where to start.
yeah,
And maybe one of them has a helpful name like main or start here or, you know, this is the most important bit, but most likely not. And then you say, of course, the maintainer knows what they all do, but
Yeah.
no reader would have a chance. So the reader would be delighted if it was just like, program.go, and everything was in there. And they can use their IDE to navigate.
Yeah, I agree.
But either way, it's fine. So yeah, so walk us through this test then.
Okay, this is the test for the user. We have in our data we have a user. We have a user. Should I call it schema or model?
Yeah.
We have a user, and now we need to test all those database methods that concern themselves with the user. Inserting a new user, fetching an existing user.
Yeah.
Verifying that a user exists, and such kind of functions. Okay, so here we start by calling our helper method test database that actually initializes the container for us and returns an ready to use store object. Context is just for signaling, and primarily for signaling in this context.
Yeah.
Okay,
New users.new takes the context.
Yeah, takes the context, and two fields, one email and one password that we expect to be returned in this user's object.
Mm-hmm. Why do we have to call some users method and then call new on the result? What does that return? Oh, a user still.
Okay. This is now the abstraction I was telling you about. I don't know whether I did it right, but let me show you. You see these users. Let's go over to it. So at the beginning, I was using two databases. I wanted to find which one I was more comfortable with, and I found out that later that I was comfortable with Postgres. So until that point that I found out that I had to abstract the methods. I discovered the methods and put them inside an interface. You can see these are all. Let me show you. Where is the interface? Let me show you. Here's the interface.
Yeah, this is a really common problem, isn't it? Which I'm sure everybody will have faced at some point.
Yeah.
Is you need to store stuff persistently, but it's not just one kind of thing. It's multiple things. You need to store users, you need to store something else, you need to store this other thing.
Yeah,
so what do you do?
Exactly.
Do you have 3 different stores for 3 different things? Or do you have one store that can store 3 different things? I don't think there's a right answer, really, is there? It just depends on... Again, the code will tell you. When you look at the code that calls this, does it make sense, or are you jumping through crazy hoops?
At the start, actually, to be honest, at the start, I was just going with the flow and my instinct. At the start, I was trusting my feeling rather than common sense. So as long as I felt good, and I was trying to avoid as much as possible blockages, I just wanted to keep my dopamine levels high, just keep going.
Absolutely.
So
I think that's right. But then once you've sort of been through that process, you might well come back to this and go, now I know which bits I can chop out because I don't need them.
Exactly what we're doing now. So
sometimes we create extra abstractions just to help us think about what's going on, don't we? And then once we know, we say, actually, we don't need these abstractions long term, we can get rid of them.
Yeah, I'm sure with time I wouldn't even need all these abstractions I've put here, but that's a discovery process, right?
Yeah.
So I was explaining why we are calling the users method so that we can call the new method on the users, So here, what I did here, I realized that users, to do operations on the database on users, you kind of have different method signatures that differ from other database objects like URLs. So I just put them together in anything that deals with user. I put all those methods together under this nice interface here, and anything that deals with URLs under this nice interface here. So it was a discovery process rather than a premeditated approach.
Yeah, and you might like to think about this option is one way we could think about this is, if we go back to that test for a moment, we can see what, this is what the user sees. When they're using your library, this is what they have to do. This feels like paperwork. It's like, oh, why can't I just call new user? Instead, I have to call some user's method. I get a user store, and then I call new on that, and then I pass it this, and I pass it that, and it gives me something back. It feels like I'm doing too much work. What I want to do is just call new user. If this line of code sits behind that function, fine. I don't care. I won't see it. You make it as complicated as you like internally, as long as I don't have to see it.
Yeah.
And you might well find that actually what makes sense to the user, just calling new user, is what makes sense to you as well. And you just create a new user method which does everything it needs to do to talk to a persistent user store.
Yeah, true. Actually, I'm writing that down so that I can really look at it later.
And this is why I have a sometimes annoying, remorseless insistence on the main function and the tests, because I want to refine them, make them shorter and shorter and shorter and more convenient.
Yeah.
Because that just leads to a good design in the end. Not only will people enjoy using your library, which we all want, but it'll just be better. I don't really know why this works. All I can tell you is it does. So it's a really useful exercise, isn't it, to just work through the program yourself, following the flow of execution, just reading the code going, does this code still make sense, knowing what I know now? Or can I simplify this?
Sure.
So, sometimes, maybe you can't, and you just say, well, then I'm just going to create a new user function which does nothing other than call this. That's okay, that's a very cheap refactoring, but it makes your API much nicer.
Yeah, I agree.
I think that's a characteristic of the really great engineers and developers that I've known in my time, is their understanding of the importance of your API. It's something they really, really take seriously. And not just the names of methods or the parameters and things, it's also error returns, isn't it?
Yeah. Actually, that's something, okay, I don't know whether it's relevant in this context, but it's something I used to have way back when I was writing Java. I know Go is a good language, but Java had there's something good about how error handling in Java, that you would just extend one main error class and have your specific error defined, and just check whether this error you're getting is an instance of this, and you can have it lets you, in a nutshell, write very minimal error classes or error logics, and just have them all in one class.
Yeah, and I think, how many times have you seen people just like, they catch some error and they return an error as just like error, or invalid. Just says nothing basically, other than just, no soup for you.
Sometimes
and it's not, if it's not that they don't know how to do it better. It's just they're almost sort of trying not to think about it, aren't they?
Yeah.
They're like, I'm sure this error won't happen. This is what everyone complains about in Go, isn't it? That they're constantly writing if not equals nil. But what are you going to do? I mean, those errors are going to happen. So you either catch them or you don't.
Yeah, it forces you to catch them at that point of happening, Yeah.
I like to embrace it. I think, my program is going to be mostly error handling. Fine, let's do it really well. Let's return really helpful and specific errors containing all of the information that the programmer wants to see, because it's likely going to be me. And what I don't want to see is my program crashed at 3 a.m., service went down, and the error was just error.
Yeah.
I'm going to find the person responsible for that and harm them. It's not that they couldn't have provided that information. They just didn't bother, or didn't want to, or just weren't taking it seriously. They're like, programmers like to think about the happy path, don't they?
Yeah, actually, that's true. That's the default.
We are optimists as engineers. We
Yeah,
hope our code is going to work. Otherwise, we wouldn't have written it like that. But then we have to
yeah,
turn around and say we have to put the other hat on, don't we? And say, now I know from experience that in fact it won't. There will be bugs and runtime errors and invalid data and all of this sort of thing. Third-party service unavailable. So what am I going to do? I'm going to, do a bunch of engineering around that stuff
yeah.
to make my program as resilient and graceful and helpful as
You,
possible.
you
So
know, some kind of bugs who usually want to make you feel like you need some divine intervention because when you have a bug that takes you 2 days to, to find or even more, I mean, you kind of run out of options.
yeah,